In today's note, we're just going to go over some of the properties of a quadratic relation. Now, some of this you may have seen already, and this may be familiar from the last note, and some of it may be new, but we're just going to go over it, cover it again, and you can kind of use this as a summary of all the different properties. So the first thing is, the key thing, the graph of a quadratic is called a parabola. And again, that's what the U shape or the N shape is called. So that U shape, depending on the opening, or that N shape, that's called a parabola. And that's the general form that a quadratic forms. The key characteristics, so the first thing, the vertex, we talked about it before in the last lesson. And again, the vertex is where the axis of symmetry and the parabola meet. So we can see our axis of symmetry, this red vertical line. It crosses the parabola right here, and we can see that's our vertex of -3, -4. You could also say that it's the lowest or highest point of the vertex, again, depending on which way it opens. The axis of symmetry, we can see here in red, the axis of symmetry is a vertical line that passes through the vertex. Now, it's not always going to be shown, but you could draw it in if you wanted to. And that vertical line, when it passes through the parabola at the vertex, what it does is it divides the parabola into two equal halves. So basically, the reason it's called the axis of symmetry is because the parabola, or the quadratic, is symmetrical on both sides of this line. The optimal value is specifically the y value of the vertex. And again, it's the maximum or minimum point of the vertex depending on the opening. And the reason that we look at the y value of the vertex for the optimal value is because we see the arrows at the top here on our quadratic. Those are increasing, or they're going to be increasing forever, or extending forever, up, and they're slightly spreading out. Again, depending on what the parabola looks like, it may be spreading out more or less, and that's what we'll look at in the next lesson. But they're increasing up and spreading out left and right. The same thing would be true if it was flipped. It'd be increasing down or decreasing continuously and spreading out still left and right. So because they're continuing on forever, spreading out left and right, we're never going to have a maximum or minimum x value. So because it keeps on going on forever, left and right, we're never going to have a minimum x value. But when we look at the y values, we will have a maximum or minimum depending on which way it opens. The x-intercept, so we've talked about x-intercepts before. It's where the parabola crosses the x-axis. And again, that's true for kind of anything. The x-intercept is always where it crosses the x-axis. A couple things. A parabola can have 1, 2, or 0 x-intercepts. So in this example we see here, we have 2 x-intercepts. It crosses the x-axis twice. We've seen examples where it can only have 1 x-intercept, where it only crosses once, where basically the vertex is on the x-axis. And we haven't seen examples where there is 0, but if we look at our graph or our grid, if we had a parabola that looked something like that, we would have no x-intercepts like that because it was above the x-axis and it's opening up. And we can also look at something like this. We would have no x-intercepts there either because it's below the x-intercept and or x-axis and opening down. So those are 3 possible scenarios. The x-intercepts, we've also mentioned that they're also called the zeros or the roots. So just some new terminology that we're going to be looking at. And then the y-intercept. The y-intercept is where the parabola crosses the y-axis. And again, it's fairly straightforward. The direction of the opening, we've talked about this. We should have noticed from the last investigation that if a is greater than 0 or positive, the parabola opens up. And if a is less than 0 or negative, the parabola opens down. So again, looking at that a value, we've talked specifically about this form, y equals ax squared plus bx plus c. That a value is what we're looking for to tell us the direction of the opening. One thing that's new that we haven't really talked about is the step pattern. And to graph a parabola, we can use a step pattern. And the way the step pattern works is that beginning at the vertex, we move one unit to the left and right, and then up or down a units. And a units is going to be dependent on the equation. And then what we do from then, once we get to that point, then we move over 1 again, and then up or down 3a units. Then over 1 again, and up or down 5a units. And the a value is the same one that we talked about with the direction of the opening. It's the leading coefficient on the form of a quadratic, y equals ax squared plus bx plus c. If a is positive, you go up, and if a is negative, you go down. So again, that's that opening up and opening down. So in general, the formula is 1a, 3a, 5a. That's the general step pattern. The a value, again, you get from the equation. And so basically from the vertex, you move over 1, up whatever the first step is. Then that's your point. Then from there, you move over 1 again, up or down whatever the next one is. Then over 1 again, and then up or down 5a. So as an example, we can see an example here. Here the leading coefficient is 2, so that's my a value. So if I have the general pattern 1a, 3a, 5a, 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. So that's where that a value is going, and that's how we get our step pattern. And we can see here, from the vertex, we move over 1, and then our first step up is 2, and that's a point. Over 1 again, the next step up is 6, and there's a point. Then over 1 again, the next step up is 10, and there's our next point. And then you can repeat the same thing on the other side because it's exactly symmetrical. So you move to the left 1 and up 2, there's a point. Move over 1 from there, go up 6, there's another point. Move left 1 again, go up 10, there's your next point. So that's kind of how the step pattern works, and we'll look more specifically at it when we're graphing specific types of graphs. But again, this is just a summary of kind of the key points of a parabola, or the key characteristics of it, some of the key points that we can find, as well as the direction of the opening, and an introduction to the step pattern.